All right, this is 2.3, and we are doing absolute value inequalities. Now, we did some absolute value solving not too long ago. And remember, we had to, like, if it was absolute value of x plus 3 equal to something, we had to take it into different things where one was negative and one was positive. Now we don't have the equal sign. We have an inequality, a less than, greater than, less than or equal to, greater than or equal to signs. So, some rules to know. If you have an absolute value of something less than an absolute, less than something else, we'll call it K, then this can be rewritten as negative K less than A less than K. Now, notice we did split this out into negative and positive. So we're essentially doing the same thing, just a little bit different. Well, let me get rid of those arrows. All right. So given the same way, if you have an absolute value greater than K, and A can or K can be, they're just variables, it can be anything. You write it as this is very similar. So A less than negative K or A greater than K. All right. So that's how you write those if you see them that way. That will help you get started for this chapter. There are some rules. To actually, you know what? Let's just leave this up here for fun. There are some solving an absolute value inequality rules. It's just a checklist of what to do. So isolate the variable, the absolute value, by itself. Rewrite it using one of these rules, and then solve. And then graph the critical numbers and check your values. See um, which one works, which one's the solution, which one's not. All right. So let's start on some fun stuff. Actually, no, I'm gonna leave these up. I already said that. All right. Let's do 2x, absolute value of 2x minus 1 and absolute value greater than 7. So isolate the absolute value by itself. That's already been done. Absolute value is here by itself on the left-hand side. Now, using the rule, this rule, that A is greater than K, we can rewrite this. We would rewrite it as I'm sorry, no A's, 2x minus 1 less than negative 7. You see that? Um, and then the next one would be 2x minus 1 greater than just 7. That's using this rule right up here. Yeah, all we do is solve. And from here, it's pretty much straightforward as far as what you need to do. So let's solve for x for each inequality, graph it, write our notation, and then check our solutions. So let's do that. Solving for x for this one, we add 1 to this side. We also add 1 to this side. This turns into nothing. This turns into a -6. This is 2x less than -6. Okay. Now, this is a multiplication right here. We're going to kill that by dividing. So this is x less than -6/2, which is just what? How do you convert 6/2 to something meaningful? So 2 will go into 6 how many times? So x is actually equal to -3. 2 will go into 6 3 times, and it's negative. So there's one. The next one, let's solve it. Let's just add our 1 to both sides. This gives us nothing. This gives us an 8. And this is 2x greater than 8. Divide our 2 out. And this is x greater than 4. Because 2 go into 8 4 times. Now, we need to graph this. Because if we don't, then we won't know our intervals. Let me do something here. And I'll do it actually just right here. We knew that this was a -3, so we'll do there. Now, handy dandy number graphing line. Just poof out of the air. And now we need to write down our interval notation. So this one is x is less than, not less than equal to, but less than -3. So find -3 and put an open dot on it. Now it's less than -3, so we draw our line this way. This one is x is greater than 4, not equal to, just greater than 4. So we have an open dot. And if it's greater than 4, we write our line that way. Okay. So now we can write our notation. Excuse me. So we have this one that goes off to -infinity, and this one, which is just -3 open. We have this in between, this space in between, which is just -3 to 4. And then we have this space here, which is 4 to infinity. Now we get to check our solutions and do more work. It's going to be great. Let's do some more of this. Let me expand this, see if I can. Look at there. More screen space. That's valuable stuff. All right. So now let's write down our notations right here. Sure. Okay. Let me block this off so we don't get confused. All right. This is a negative something, -infinity to -3. This one is a -3 to a 4. And this one is a 4 to infinity. So we need to write our graph, our test graph here. I'll expand this. And these are our test points right here. And our solution checker right here. So what test point should we choose for this top one? So -infinity to 3 is here. We can't choose the critical point, but we can choose the one right next to it, which is -4. Let's choose that one. For the middle one here, the -3 to 4, let's choose 0 since it's part of it. Would be an easy one to solve with. And 4 to infinity, let's just choose the next number, which is 5. And there's our points. Now, this is the inequality that we need to check. So let's check that. So it's well, this is okay, yeah, let's do it this way. 2, and that is a 2, believe it or not. -4, replacing the x with a -4, minus 1, absolute value greater than 7. And then this one would be 2 times 0 minus 1, absolute value greater than 7. And then this one would be 2 times 5 minus 1, getting ahead of myself, greater than 7. Now, let's solve this top one. This is just, well, I'm not going to rewrite it. So 2 times -4 is just what? Well, we'll do it in our head. What? I mean, we can do this. Look, 2 times -4 is what? It's -8. Well, -8 minus 1 is -9. And -9 is not greater than 7. Do you agree? So, but we're missing something. Um, you would agree that -9 is not greater than -7, but let's look at this even deeper here. We've said that 2 times 4 is -8. 2 times -4 is -8. Minus 1 is -9, right? But we forgot something. We still have this absolute value here. Absolute value of -9, or the absolute value of any negative number, is the positive of that number. I don't know if we talked about that, but there you go. You should have known that from past, but there you go. So now, is 9 greater than 7? Yeah. So this checks out. It's a good one. We got to watch for that. We can't forget those inequalities. Can't forget the absolute values. All right, let's move on. So, in this one, 2 times 0 is obviously just 0, and we're left with -1. Well, that -1, let's do it this way. We're saying we're left with -1 absolute value, which is actually just 1 greater than 7. Now, is 1 greater than 7? No, greater than 7. All right. Now, let's do this last one. This one, we plug in a 5. So 2 times 5, that's actually a 5. I can't even, it's a 5. So 2 times 5 is 10, minus 1 is 9. So if we have a 9 absolute value greater than 7, absolute value of regular 9 is just regular old 9 and 7. Is 9 greater than 7? Yeah. Found 2 solutions. Well, that was pretty good. All right. So what's our answer? What do we do with this information? Well, our answer is these two, this top one and this bottom one. But we should probably graph it. Yeah, we like to graph stuff. So let me just graph it real quick. I don't want to cover up my stuff. Yeah, I cover this stuff up though. All right. Graphing this is fairly straightforward. We've already actually kind of done it, but we're -3 to infinity. So -3 out to infinity, and then 4 out to infinity. And that's the graph of it. Um, so yeah, that's the solution. Um, let's move on. All right, now here we go. Now we're getting somewhere. Okay, that was one example. Let's do another. These are so fun. We should do more. I I actually think that. Just let you know that. So this is 3 absolute value of 5 minus 3x. Absolute value. End absolute value. Less than 12. Okay. Now, the first thing we got to do is isolate the absolute value. Is it isolated? No, we got this 3 in front of it. What are we going to do with that? Well, this is understood to be multiplication. Is it? Well, how could 3 be multiplied by absolute value? Well, it is. So the way we take it out is we push a 3 right here. There we go. Now this becomes, oh, I'll write it. Well, I'll write it right here. This becomes just absolute value of 5 minus 3x. Absolute value less than, what's 3 into 4? I mean, I just told you the answer. What's 3 into 12? It's 4. Okay, now we have the absolute value by itself. Let's go ahead and write this the way that our properties let us, or our rules let us do it. So this says if A absolute value less than K, then we can rewrite it like this. Now let's do that. So we'll have a negative 5 minus 3x less than A. Wait a minute. Wait a minute. Okay. It's like 9 o'clock. So I'm getting tired. So A here, it represents this. So come on, we got to write it as -4 because 4 represents the K less than 5 minus 3x less than 4. Yeah, it makes a lot more sense. All right. Now we have to solve it. Now to solve this, we've done these before. What you do to one side, you have to do to all 3 sides. So treat everyone equally. This is -5, so we'll be taking that out. -5 and -5. So -4 -5 is just what? -9. Good grief. -9 less than -3x less than 4 minus 5 is what? -1. All right. Now we still have this pesky -3x. Now, remember the rules here. When I do this, because this is multiplication, when I do this, what happens? When I do this to all sides, what happens to these inequalities? Yeah, what happens to them? So they get flipped, just like this. X is in the middle. Negative, excuse me, -9 divided by -3. Well, what can we write that as? Is that just, oh, see, you know, give enough space. Space is important in math, not space you fly in space, just space that you can write on. Oh, that's a 3. The negatives go away, and that's a 3. And the 3 And then what is this? This is -1/3. This is just 1/3. Now we don't have to simplify it or make it into a decimal. We know how to deal with 1/3. So it's fine. Now, which one's less than? Is this less than 3? It is. Let's rewrite it so it's better on us. Let's rewrite it as 1/3 less than x less than 3. Notice we flip the signs again because we're just moving everything back around. All right. All right. So we did all that to figure out that this is what we're going to be working with. So the first thing we need to do is graph that. So let me just get rid of all this extra here. Let's start up here. Let's graph this thing. Yeah. All right. So to graph it, it's a 1/3. So let's look at 1/3. It's probably about right here, and it's less than, so it's not closed, it's open. So 1/3. And then we have a 3. So 3 right here. And x is in the middle. So we have something like this. To test our intervals for to test our intervals, we have okay. So just like the other one, we still have this way that we can test and this way we can test. So let's write our notation. We have -infinity to 1/3. And then we have 1/3, 2, 3. And then we have 3 to infinity. Let's test those. I'm running out of screen real estate. I wonder if I can do this. Ooh. Making more screen real estate as we speak. Look at that. That is awesome. Okay, good. So let's do a -infinity to 1/3 interval right here. Draw our line. So we get a 1/3 to a third. To a 3. Draw our line. And we get a 3 to infinity. Draw our line. Block it off. Make a test point section. Make a substitution section and a solution section. All right. Here we go again. So looking at our graph, we have on this one 1/3 all the way to -6. So our test point should probably be 0 since it's included in this line. Now the next one, 1/3 to 3, our next point is 1. Let's try it. And our next one, 3 to infinity, is a 4. Remember, we cannot pick critical points, so we couldn't pick the 3. Now, substituting this, whoa, okay. This is a 3 absolute value, 5 minus 3, and then we put a 0 here, less than 12. Now, we could have used the already solved inequality, our absolute value, which is fine. We could have done that. This way works too. We'll just have to move that 3 over every time. In fact, we can do it now and save ourselves some trouble. So remember when we moved that 3 over, This is multiplication. We divided it out on this side. We divided it on this side. That line's still there. So 3 are going to 12 how many times? Yeah, 4 times. So we can just write a 4 here. So in actual reality, we would have a 4 and no 3. And it makes it a little more simple. There. In this one, we will write the absolute value of 5 minus 3 times 1 and less than 4. And in this one, absolute value of 5 minus 3 times 4, absolute value less than 4. Well, let's solve these. So this one, 3 times 0 is just 0. So you're left with 5. Absolute value of 5 is just 5. So is 5 less than 4? No. No, 5 is not less than 4. Okay. So this would have been 5 and this would have been 4. Sorry, I like to write those out. This one is 3 times 1, which is just 3. And then 5 minus 3 is just 2. Absolute value. And then it turns out to be just 2 because the absolute value of 2 is just 2. And 2 less than 4. 2 is less than 4. And this one, we have 3 times 4, which is what? Okay, it's 12. So we have 5 minus 12, absolute value, less than 4. And 5 minus 12 is what? It is negative 7, absolute value of negative 4. That turns into, because it's absolute value, just 7 less than 4. Is 7 less than 4? No, it is not. So we have 2 no solutions. So how do we graph this? And how do we look at it? And what's our answer? Well, the answer would be the one that the interval notation that we said that, hey, this is a solution. There's your answer. So that's acceptable. All right. Now we shall move on to another example. Yet another example. These examples are getting more and more fun. Okay. Well, let's clear the screen and clear the rest of the screen. All right. Now, I'm leaving the rules up here because we're using them every time we do these. And I wanted these to stay in our head as we do our work. So, okay. According to the book, if you have an absolute value, well, let me write it here. If you have an absolute value, that's an A. Let's just use X. There we go. Absolute value of X less than a negative number, then automatically there is no solution. If you have an absolute value less than a negative number, there is no solution. But if you have an absolute value greater than a negative number, all real numbers will work. So that's something to remember. That might help us make some shortcuts later. So let's solve this one. We have absolute value of 4x minus 3 less than negative 6. Now, to solve this, we need to look at our rules. We see this rule, we can rewrite it as, but we also see this rule that says absolute value less than a negative number has no solutions. So I would say that this is no solution. Why go further? Why do anything else with it when you already know there's no solution? Example though. All right, let's move on to another example. All right, this is an absolute value of 8x plus 1 greater than -15. Now, if we look at our little handy-dandy chart here, if it's greater than with a negative number, all real numbers will work. So, should we solve it, or should we just say any real number will work? Well, if any real number works, we can get our intervals out of it. We probably should get our intervals out of it, but we know that all numbers will work. So all solutions work on this one. Now, will the book ask you for intervals for those? Um, yeah, I believe it will, because you still need to know the intervals. So let's solve it. We know it's all going to work, but let's go ahead and solve it. So to re the integral, I'm sorry, the absolute value is by itself, so we can't simplify that. So to rewrite this, we use our properties here. So this is a greater than. So we rewrite this as using this property here, 8x plus 1 less than. So that's a negative k, and we already have a negative number, so that's just going to be 15. And then this one is an 8x plus 1 greater than just k, which is -15. Excuse me. And these are no longer absolute values. These are just inequalities and the same stuff we've been seeing. To solve these, let's go ahead and solve them and get our points. -1 on this side, -1 on this side. Changes it to 8x less than 14. Divided by 8 on both sides. 8 into 14. This is what is it? What's 8 and 14? Does anybody know? Can we even do that? Is that something we can do? Am I tripping you up? So 8 doesn't go into 14, does it? So how do we do this? It's an improper fraction. So how do we display this? Well, we know each number will go by 2. So let's just do that. So this is x less than 2 going to 14 7 times, and 2 going to 8 4 times. 7/4. No need to try to write it as an improper, a proper fraction. That's just fine. We know how to deal with that. And this one is, well, we got a -1, -1. This is 8x greater than, oh, -15, -16. We have an 8. That's not a -8, so we're not changing signs. This is 8 is greater than just negative, old plain -2. Excuse me. Well, let's graph this. This should be fun. Okay. So x is less than 7/4. This is a positive 7/4. And my imagination, 7/4 is somewhere, I don't know, close to the end of here. So let's just write it as open because this is just a less than. And x is less than. So, let's go less than. There we go. And x is greater than -2. What? So what did I do here? X is greater than -2. Now, we have overlapping numbers. Hmm. But it's true. X is greater than -2. So -2, it would be right here, and it would be an arrow this way. So to write our intervals, um, we would just write it the same way we normally write it, but we could start here and here, just like we normally would. So we have negative infinity. We know it can go all the way up to 2, or -2 at least. We have this space in here, which is just -2 to 7/4. And then we have 7/4, 7, going all the way to negative infinity. So that's our plots or intervals. So let's go ahead and try to solve these. Now we already know that all of these are going to be, remember, they're all going to be, real numbers are going to work. So we found our plots. There's no use to try any numbers because they're all going to work. So this is our answer. These are our answer. Sometimes it's good to think about what you're doing because we already said that this, all real numbers are going to fit in this equation. We've found our intervals. We're done. No need to check because it's always going to be a solution. Okay, so for your practice work, your practice work will be 2.3, and it's going to be 1 through 18, blue. I want to see all the work. I want you to make sure you get all the intervals and check them. And it will take lots of paper, and it's okay. And good luck.